1945, the final gasps of the Pacific War. The largest, most brutal industrial meat grinder in human history is spinning at full speed. If you were a pilot in the Imperial Japanese Navy at this precise moment, huddled in a trench on Okinawa or floating at 7,000 meters, in the fragile aluminum cockpit of a Zero fighter, there was one sound you prayed to your gods you would never hear. It was not the boom of artillery, nor the low rumble of thunder. It was a unique, banshee-like shriek, a high-frequency whistle. It sounded like death itself was pursing its lips. When you heard that sound, the countdown to your death had already hit the 3-second mark. Above you, the cloud layer would tear open. A massive, dark blue silhouette would plunge down at an angle and speed that defied physics. Dropping like an angry meteorite, your retina would not even have time to register its outline before 6 tongues of fire enveloped you. Woven from 12-point, 7mm heavy machine guns. That was not just shooting, it was a chainsaw cutting through the sky. In the face of this flying chainsaw, neither flesh and blood nor thin, aluminum skin stood a chance. This was the F4U Corsair. American pilots called it the Cadillac of the skies, but to the survivors of the Japanese military, it was simply the whistling death. For 3 long years, the Japanese military feared this monster, yet they never truly understood it. Why was it so fast? Why did it seem impossible to shoot down? How could a machine that heavy perform such impossible acrobatics in the air? To the Japanese High Command, the Corsair was a black box made of steel, aluminum, and alien technology beyond reach. Until early 1945, fate, it seemed, decided that the tragedy of the empire was not complete without a twist. Fate decided to give Japan, struggling in the mud and fire, a final gift. On a day near the Japanese mainland coastline, a US Navy F4U Corsair suddenly fell from the clouds. It had not been shot down. There were no lethal bullet holes on it. Whether it was a mechanical failure or fuel starvation, we may never know. The massive propeller froze in the cold air. The American pilot was forced to ditch. The massive airframe skipped like a stone across the water, slamming into the sea. The pilot bailed out and was quickly captured by a Japanese patrol boat. But what made the eyes of the commander light up was not the surrendered American, but the aircraft bobbing in the waves. It was damaged. Its wings were bent and broken. It had taken on water, but it was structurally whole. For the first time in 3 years, Japan had captured a living, breathing beast. This Corsair was immediately classified as a top-secret asset. It was salvaged overnight, loaded onto a ship and secretly transported to the beating heart of Japan aviation industry, the Yokosuka Naval Air Technical Arsenal. Accompanying it were top experts from the Tachikawa Army Air Technical Research Institute. This was an autopsy team comprised of the sharpest minds in the empire. Among them were chief designers from Mitsubishi Heavy Industries, professors of fluid dynamics from Tokyo Imperial University, and engine authorities from Nakajima Aircraft. In years past, these were the men who had designed the Zero and the Hayabusa, planes that once ruled the skies. But at this moment, standing in that cold, damp Yokosuka hangar, smelling of mold and old oil, no one spoke. Harsh industrial floodlights cut through the gloom, hitting the deep blue and enamel of the wreckage. It reflected a cold, arrogant sheen. Even lying broken on the concrete floor, that massive frame radiated an oppressive dominance. Standing before it, the Japanese engineers in their khaki uniforms looked small, almost malnourished. They clutched their notebooks. And calipers tightly, their eyes betraying a mix of hunger for unknown technology and dread. Their orders were simple: take it apart, understand it, copy it. It sounded like a standard reverse engineering mission. In war, studying captured weapons to improve your own is routine. But as the first American screw was turned by a wrench, as the first panel of skin was peeled back, this group of elite engineers began to realize with horror that they were not conducting a technical analysis. They were witnessing the public execution of Japanese industrial civilization right there. This autopsy would shatter the last remaining illusion of victory they held in their hearts. Let us start with the heart. Let us start with the heart of the beast, the engine that made every Japanese pilot tremble when the mechanics struggled. With the hoist to lift the nose cowling, the massive Pratt Whitney R-2800 double wasp engine was finally revealed. It was the ultimate expression of industrial aesthetics, 18 cylinders arranged in a double row. Radial formation looking like a deadly flower forged of steel. A chief Japanese engine designer stepped forward slowly. His hand trembled slightly as he ran his fingers over the cooling fins of a cylinder. In that instant, his fingertips transmitted a sensation he had never felt before. It was smooth. To smooth, it was like a piece of art. You have to understand, the function of cooling fins is to increase surface area to wick away the insane heat generated by the engine. In Japanese factories, this was usually done by casting, pouring molten aluminum into a mold. But cast fins are often thick, with rough surfaces, sand holes, and air pockets. To ensure strength, the base had to be thick, which meant poor heat dissipation. But the American engine before him completely overturned his understanding of manufacturing. He took a magnifying glass and looked closer. He saw incredibly fine tool marks. These thin, dense, deep fins had not been cast. They had been machined. Cut, one by one, from a single, massive solid block of forged aluminum alloy. The designer sucked in a cold breath. This was madness. Do you know what this meant? It meant an extravagant waste of expensive raw materials. To cut a block of aluminum into this shape, at least half of the material was turned into scrap shavings. It meant an obscene consumption of cutting tools. To machine deep grooves into such hard alloy, the wear on the blades would be astronomical. It meant they had an ocean of machine tools. In 1945 Japan, aluminum was scarcer than gold. Factories were thinning plain skins just to save material. Japanese tools lacked tungsten. Their blades were brittle as glass, forcing workers to stop and sharpen them after every few parts. But the Americans, to pursue the tiny edge in cooling, they could waste tons of aluminum in tools without blinking an eye. It was like a cooking competition. The Japanese chef uses potato peels, while the American carves the center of a cow and discards the rest. This was the gap in national power, but that was not what drove the engineers to despair. The real mental breakdown happened next. As the mechanics began to dismantle the cylinders and pistons, a young Japanese engineer tried to label the parts with tags. This was common sense in Japan. Because precision was low, every part had to be hand-filed and matched by master craftsmen. Cylinder 1 had to be paired with piston 1. If you jammed piston 1 into cylinder 2, it would seize up or leak air. Every Japanese engine was a hand-crafted orphan, but when a captured American manual indicated that numbering is unnecessary. They randomly picked up pistons from 2 different cylinders, swapped them, and gently pushed them in. Click. That smooth sensation of suction, that perfect, airtight resistance, it silenced everyone in the room. No jamming, no wobbling, no need for a file, no need for polishing paste, no need for the calloused hands of a master craftsman to feel for micron-level errors. It just slid in perfectly, as if they were born for each other. This is interchangeably. This is the soul of modern industrial mass production. In that moment, the hangar was deathly silent, save for the sound of waves hitting the seawall outside. The pen in the young engineer hand dropped to the concrete. He stared at the piston. He stared at the gleaming American piston in his hand and suddenly felt a wave of powerlessness wash over him. This did not just mean this plane was built 10 times, 100 times faster than a Japanese one. It meant that across the Pacific, in Detroit and Hartford, there were thousands of factories churning out these perfect engines like they were printing banknotes. Meanwhile, in Japan, they relied on mobilized high school girls to file parts by candlelight. How can we possibly win? How can we possibly win? This thought grew like a poisonous weed in everyone's heart. But this was only the beginning. As the dissection continued, the corpse of the Corsair began to reveal more secrets. Each one a slap in the face. Shift your gaze to the wings, the iconic inverted gull wing. That famous double U-shape. For a long time, Japanese designers had mocked the Americans for not understanding aerodynamics, thinking this was a stupid design that added dead weight just to look different. Why dip the wing down and then back up? But when they stood in front of that massive propeller, the mockery turned terror. The mechanics measured the propeller diameter, 13 feet for inches, over for meters. What does that mean? If you laid this plane flat on the ground and spun the prop, it would slice into the concrete like a knife through tofu. To tame the 2,000 raging horsepower of the R-2800 engine, you needed a propeller that huge to convert power into thrust. If they had used a straight wing, the landing gear would have to be as long as stilts to keep the massive prop off the ground. But the Corsair was a carrier-based fighter. It had to survive violent crash-like landings on a heaving ocean deck. Long, spindly landing gear would snap like dry twigs on impact. So the American designers came up with this genius solution. Bend the wing. Dip the wing down at the root and mount the landing gear at the lowest point of the structure. This allowed the gear to be short, stout, and strong enough to survive a building drop impact while lifting the nose high. To give that massive fan clearance, it was not stupidity. It was a violent aesthetic born of pure problem-solving logic. It was not elegant, but it was brutally effective. However, the moment the Japanese engineers felt truly insulted occurred when they examined the skin of the wings. A materials expert was holding a scalpel, ready to slice open the skin of the outer wing panel. He wanted to see what high-strength alloy the Americans were using. The blade sliced down aggressively. But the tactile feedback was wrong. There was no metallic screech, only the dull sound of tearing fabric. He froze. He peeled back the paint, and what was revealed was not aluminum sheet, but cloth. The hangar erupted. The Americans are out of aluminum too. This is their advanced fighter, using canvas like it is World War I. A ridiculous sense of joy spread through the crowd. If the mighty United States was reduced to building planes out of fabric, did it mean their resources were drying up? Did it mean Japan still had a chance? But this naive fantasy was ruthlessly crushed by the lab report. This was no ordinary canvas. It was a high-grade cotton fabric treated with a specific chemical process. It was coated with multiple layers of specialized dope. It had undergone complex tension testing. Once stretched over the wing frame, its toughness exceeded that of thin aluminum sheeting. And it was incredibly difficult to tear. The Americans did not use it because they were poor. They used it because they were calculated to the extreme. The Corsair was already heavy due to that massive engine and heavy armor. To ensure agility, the designers had to shed weight maniacally in non-critical areas, using this high-tech fabric. On the outer wing panels, areas that did not carry the primary structural stress saved dozens of kilograms. Those dozens of kilograms could be traded for more fuel, more ammunition, or thicker armor. This embodied the core of American engineering philosophy, absolute pragmatism, where metal was not needed. They would not waste a gram, but where strength was needed, they would not spare a ton of steel. This philosophy of save where you can, spend where you must stood in stark contrast to the Japanese mindset of sacrifice all protection for extreme lightness, a mindset that drilled holes in pilots' eats just to save a few ounces. This leads us to the next discovery that suffocated the engineers, the protection system, when dismantling the cockpit. The strong mechanics could not lift the pilot's seat. Why? Because it was too heavy. Behind the seat, they found a thick steel plate. Under the cockpit floor, steel plate. Around the fuel tank, more steel. The critical parts of this aircraft were wrapped in armor plating totaling nearly 150 pounds. Even the bulletproof glass in front of the pilot was a staggering 1.5 inches thick. A Japanese engineer held that brick-thick glass, looking through it at the distorted view of the hangar. You see, the Japanese Aerofighter had stripped away almost all armor to gain the tiny edge. In maneuverability and range, a Japanese plane was like a paper kite soaked in lighter fluid. One hit and it would incinerate. The logic of the Japanese military was cruel. The best defense is not getting hit. If a pilot got hit, it was due to his lack of skill, and he should die for the emperor. But in the American design, we see a completely different set of values. The human being is the most expensive component. The Americans understood that building a Corsair might cost a few $1,000s and a few hours. But training an ace pilot who could tame this beast and land it on a pitching deck took years. Tons of fuel and endless resources. Pilots were an renewable strategic resource. The Corsair was like a medieval heavy cavalryman in full plate armor. Maybe it was not as nimble as the Zero in a dogfight. Maybe its turning radius was not as tight, but it dared to charge into a wall of fire. It dared to go head-to-head. Even if it took dozens of bullets, turning the fuselage into a sieve, it would protect the flesh and blood inside, and wobble its way back to the carrier, and that surviving American pilot, the next day he would climb into a brand new plane, take off with vengeance in his heart, and use his survival experience to hunt down the next Japanese rookie. This 150 pounds of armor was not just steel. It was the massive chasm between two civilizations' understanding of the value of life. As the fuselage skin was completely stripped away, the Corsair's true face, as a pure killing machine, was exposed. Inside the folding wings, the engineers saw 6 Browning M2 heavy machine guns arranged in a stepped formation. This was another scene of despair for the Japanese technicians. Japanese aircraft cannons, though some reached 20 millimeters in caliber and looked intimidating, suffered from weak industrial backing. They had severe ballistic drop and low muzzle velocity, and pitiful ammunition counts, often only 60 rounds per gun. A pilot had to fire at point-blank range and count every shot like a sniper. But the Corsair was different. 6 heavy machine guns, 400 rounds per gun, a total of nearly 2,400 rounds. When these 6 guns fired simultaneously, they were not shooting, they were hosing down the enemy. Thousands of high-velocity, armor-piercing incendiary rounds per minute created an inescapable wall of fire. From hundreds of meters away, this metal storm could shred any fragile Japanese plane. Even more terrifying was the reliability of the feed system. The engineers tested the feed chutes and ejection mechanisms repeatedly. They were shocked to find that even under high-G maneuvers, this system almost never jammed. Reliable, stable, massive capacity. This was the violent answer given by American manufacturing. Beyond the guns, under the wings, they found sturdy hard points and rocket launch rails. This meant the plane was not just a fighter. It was an aerial truck. It could carry to 1,000-pound bombs, plus 8 5-inch high-velocity rockets. What is that concept? A single-seat fighter carrying a payload that exceeded that of some Japanese twin-engine light bombers. In the mud of Okinawa, to the Japanese infantry cowering in caves, this blue plane with bent wings was more terrifying than a demon. It did not just strafe. It could turn the earth upside down like a bomber, pull up like a loach, and speed away into the clouds. The disassembly work lasted a full month. Every day, the atmosphere in the hangar grew more oppressive as secrets were revealed. Originally, the Japanese engineers started with the mindset of finding weaknesses. They hoped to find flaws in the American design. Structural weak points, blind spots in the control system to write into the Air Combat Guide for frontline pilots to survive. But in the end, the thick report placed on the commander desk in Yokosuka read more like a post-mortem report on Japanese industry. Between the lines of cold data, the report screamed with suffocating despair. Its machining precision is beyond the reach of our tools. Its material strength is impossible for our metallurgy to achieve. Its design philosophy is incomprehensible to our mindset. This was the conclusion, a brutal, unvarnished conclusion. The old engineer responsible for the engine tear-down collapsed. Looking at the connecting rods and gears gleaming coldly under the lights, he muttered to himself, "How can we possibly defeat such an opponent? We are fighting a spaceship with bamboo spears." This autopsy shattered the last shred of luck in the hearts of these technological elites. They finally understood that even if Japan mobilized every ounce of strength, collected every scrap of aluminum, and gathered every skilled worker, they could not build a single aircraft that matched the Corsair. Because it required more than just a blueprint. To build a plane like this, you need a massive electrical grid. To electrolyze aluminum, you need a colossal chemical industry to refine high-octane fuel and synthetic rubber. You need the most advanced metallurgy to create heat-resistant alloys. You need universal higher education. To train thousands of workers who can read complex blueprints, you need efficient rail and shipping networks. This was a war of systems, and Japan had lost from the very beginning the existence of the F4U. The existence of the F4U was the most powerful refutation of Japan's theory of spiritual victory. It proved that, in the face of the steel torrent of modern industrial warfare, the so-called Bushido spirit, the determination to shatter like jade, were nothing more than tragic moths flying into a flame. August 1945, two atomic bombs ended the madness. That disassembled, broken Corsair eventually turned into a pile of scrap iron, vanishing into the dust of history. But its ghost did not disappear. The Japanese engineers who participated in the autopsy took off their uniforms. Many of them, carrying the deep shock and humiliation of that dissection, walked into the new factories built upon the ruins. Where did they go? They went to Toyota, which was just starting to make textile looms. They went to Honda, which was fixing motorized bicycles. They went to the ruins of Sony. They went to the restructured Mitsubishi Heavy Industries. They carved the painful lessons learned from the Corsair into the bones of post-war Japanese industry. Those lessons were: without quality control, you have nothing. Without standardization, there is no scale. Without respect for objective laws and the value of human life, you will be ruthlessly eliminated by history. If you look closely at the rise of the Japanese automotive and electronics industries after the war, you will find that the obsessive pursuit of precision, the strict management of quality control, seeds of all that were planted in that cold hangar in 1945 standing before a shattered F4U Corsair. It was the most expensive lesson in enlightenment taught to pre-industrial Japan by the Americans, using the most violent means possible. Today, when we see the unique silhouette of the F4U Corsair at an airshow, and hear that signature whistling death tear through the sky, remember, it is not just a killing machine. It is the totem, the peak of industrial civilization of that era. It is a judgment written in steel. It tells all of humanity in the coldest, most direct way. In the furnace of modern warfare, spirit cannot defeat physics. Fanaticism cannot defeat science. And a backward industrial system is destined to become nothing more than gravel under the treads of advanced civilization. If you want more hardcore breakdowns of history, deadliest miscalculations,